All right, I think we are live now. Let's get started. Good morning, everyone. Welcome back to AI Horizons, turning intelligence into impact, powered by Aeologic Technologies. I am Jubin, and I'll be your moderator for today's session. In our earlier webinars, we have seen AI enhance creativity, automate data intelligence, and redefine enterprise efficiency. But today, we are stepping into one of the most visually transformative fields of AI, that is computer vision. From monitoring production lines to managing retail shelves, from analyzing traffic to detecting safety hazards, computer vision is shaping how machines see and understand the world. And at the heart of this revolution lies smart vision systems, solutions that combine learning, edge computing, and analytics to identify, count, and classify objects in real time. Which brings us to our today's session, that is smart vision systems, AI-powered object detection and analytics. Over the next 35 minutes, we'll explore the following things: how AI-driven vision systems are deployed in real-world scenarios, from factories to smart cities, the technology stack behind object detection and real-time analytics, how to integrate computer vision with IoT, edge devices, and enterprise dashboards, and finally, how to start building your own intelligent vision systems with scale architecture. Joining me today is Deepchand, our team lead mobility here at Aeologic Technologies. He has led multiple deployments of AI vision systems across manufacturing, logistics, and infrastructure for projects, from automated counting systems to camera-based analytics. Great to have you, Deepchand. How are you?
Yeah, thanks, Zubin. Hi, everyone. It's a pleasure to be here. Computer vision has become one of the most practical and high impact area of AI today. It's not just about recognizing images anymore. It's about interpreting live video, detecting anomalies, and making data-driven decisions in real time. And that's where smart vision systems comes in, combining AI models, edge devices, and data analytics to create a digital eye for machines. Today, we will decode how these systems are built, what technologies power them, and how enterprises are using them to improve efficiency, safety, and visibility.
Great, great. And as always, we have one wonderful demo as well in between the sessions. So stay tuned at the very end of this today's session. So let's start with today's session from the basic. What do you mean by smart vision system? What is smart vision system?
Okay. Smart vision systems are AI powered setups that use cameras, sensors, and deep learning models to detect, identify, and analyze objects or activities in real time. They go beyond traditional CCTV systems. Instead of just recording video, they understand what's happening in the frame. When we talk about smart vision systems, we are referring to an entire category of AI powered setups designed to make machines see and understand the world just like humans do, but with far more speed, accuracy, and consistency. These systems combine cameras, sensors, and powerful deep learning models to detect, identify, classify, and analyze objects or activities in real time. Unlike traditional CCTV systems that simply record video, smart vision systems actually interpret what is happening in the frame. Instead of producing hours of footage that someone must manually review later, they convert every moment into meaningful insights. This ability to understand context is what makes them smart. A typical smart vision system follows a simple three-step loop. First is capture. Cameras capture camera or sensors record visuals from factory floors to highways to retail outlets. Second is interpret. Deep learning models process these visuals to recognize patterns, objects, and behaviors or anomalies. Now, last one is act. The system triggers alerts, automate actions, or provide analytics that help decision makers respond instantly. So, these capabilities make smart vision systems useful across a wide range of industries. For example, manufacturing. On production lines, vision systems can count items moving along a conveyor belt detect defects like scratches or misalignment, measure dimensions, or verify whether a product meets quality standards. They work at they work at speed and accuracy levels that manual inspections simply cannot match. Many factories now rely on these systems for 24 into 7 quality control, reducing wastage and improving overall efficiency. Now, second is retail. In modern retail environments, smart vision systems help analyze self inventory, detect empty racks, track footfall, and understand customer movement patterns. This enables stores to improve product placement, optimize stock replenishment, and enhance customer experience. Even automated checkout systems which identify products without scanning barcodes are powered by Vision AI. Now, third is our traffic and infrastructure. In traffic and infrastructure, smart vision systems are already transforming cities. They help authorities identify vehicles, track congestion patterns, detect violations like speeding or red light jumps, and even support emergency responses by recognizing accident in real time. This results in smoother traffic flow, improved enforcement, and safer roads. Now, the last is warehousing and logistics. In warehouses, vision systems automate inventory counting, detect pallets, monitor docking bays, and ensure correct loading and unloading processes. They reduce manual labor, minimize errors, and bring real time visibility into operations, a crucial advantage for large scale logistics and e commerce companies. In essence, smart vision systems turn raw visual data into actionable intelligence. They operate like a digital eye backed by a powerful brain, continuously observing and making sense of everything happening in their environment. Whether it's improving safety, ensuring quality, reducing operational cost, or enabling automation, these systems are becoming a critical component of modern industry and smart infrastructure.
Awesome. Thank you for that detailed explanation. And I think you also included the various use cases that where we can use the smart vision systems, but definitely we'll double dip on that later. Now, moving on towards the next question, Deep. Can you walk us through the technology layer? Like, how does AI actually detect and identify these objects?
Sure, Juvin. Let me break it down step by step because behind every object detected box you see on the screen, there is full technological pipeline working in milliseconds. So first, let's take image acquisition, which is the eye of the system. You can say this is the input part. So everything begins with capturing the visual data. This could be an IP camera on a highway, a mobile camera on a shop floor, a CCTV in a warehouse, or even edge device like Jetson Nano on a robotic arm. These cameras continuously stream images or video frames into the systems. The quality of detection heavily depends on this stage. Factors like resolution, lighting, angles, and frame rate influence how well the AI can understand this scene. Okay. Next is our pre-processing. Like before feeding the input to AI model, we need to clean the visuals. So once the raw images arrive, the next step is pre-processing, which is basically preparing the visual input so that model can handle it efficiently in a fast manner. This includes resizing the image to the model required input dimensions, normalizing pixel values, enhancing brightness, contrast, removing noise, cropping or masking irrelevant areas. So think of this stage as cleaning and formatting the data before the AI brain start analyzing it. Now, our third part is model inference, which is the brain at work, the real brain, which will detect the things in the images. So, this is the heart of the object detection. Deep learning models such as YOLO V8, SSD, Retina Net, and faster RCNN process each frame to identify what objects are present, draw bounding boxes, classify them like car, person, helmet, palette, and estimate confidence score, that how much the system is confident that the specific type of an object. Now, models like YOLO V8 can process 30-60 frames per second, giving truly real-time detection. So the choice of model depends on the use case. For example, YOLO is great for speed, faster RCNN excels in accuracy. Lightweight models run efficiently on edge devices. So this is the moment when the system actually understands what is happening in the frame. Now our fourth part is tracking and counting. Now our processing part is done, and now we need to track. So detecting an object in a single frame is not enough. Uh, in real world scenarios, we want to track the same object across multiple frames, like whether it's a vehicle moving across lanes or a pallet being lifted from one bay to another. Algorithms like deep sort, bytrack, and Kalman filters step in here. They assign unique ID to each object and follow their movement. So this enables object counting, path tracking, zone-based analytics, heat maps, speed estimation, behavior understanding. For example, in a warehouse, we can track how long a pallet stays in a bay, or how many people enters um, a restricted area. Okay. Now, our fifth part is analytics layer, which is turning detection into insights, mean making a real data which human can understand. So the final stage is where the data becomes truly useful. All detections and tracking events are aggregated into dashboard and reports. This layer provides insights like occupancy levels, throughput, queue length, traffic density, violations, and anomalies. This is what business ultimately care about. Actionable intelligence, not just boxes around objects. Okay. So what is now where all this runs? This will definitely run on something like a cloud, or you have personal server with high and GPU. So the entire pipeline can run either on the edge for ultra low latency and privacy. On the edge means if you have a phone and you have uh, uh, put your whole AI model on that phone. So it will definitely work faster because it don't doesn't need to send the data over any server to process the frames. So on the edge for ultra low latency and privacy, on the cloud when scalability and heavy computations are needed. So choosing the right setup depends on latency requirement, bandwidth availability, and cost. In short, object detection is a full pipeline from capturing frames to turning them into meaningful insights, all happening in the real time.
Great, thanks a lot for that explanation. And if we dumb it down and make our viewers understand it more on a very high level, right? So there are 5 steps for achieving these object detection, and how that works is, first we get the image or the video stream, and then we process on that video, and that processing is done with the help of any AI model.
AI
In
model,
this
right?
case, we can use a LLM or SSD or RCNN, and then that data is transferred to another platform, and then over to the cloud. It's just visible to the user.
Yes, yes,
Awesome.
yes, yes.
Great. Now let's move on to the next question, Deep, right? Can you share some examples where these systems are already driving business outcomes?
Absolutely, Jubin. Smart vision systems aren't just theoretical concepts anymore. They are already producing measurable business outcomes across industries. Let me walk you through a few high impact real world applications we have either deployed or seen widely adopted in the industry. Uh, First of all, we will do this like a user story, like a product story, not a user story, like a product story from manufacturing to a retail store. Like first of all, we will discuss about manufacturing line monitoring. In the manufacturing environment, vision systems have become the backbone of quality assurance. Cameras placed along conveyor belts or assembly lines can count items, right? Verify alignment, detect defects like scratches or cracks, and even measure dimensions with millimeter precision. So what makes this powerful is a consistency. Unlike human operators who may get tired of or miss subtle defects during long shifts, the AI maintains the same accuracy 24 into 7. So many factories that are implemented AI-driven defect detection have reported reduced work, lower wastage, improved throughput, uh, and faster and identification of bottlenecks. So in short, vision system doesn't just monitor, they optimize the entire production process. So now our product has been has manufactured. Now it is moving to warehouse. Now second part is warehouse and logistic object counting. In warehouse, the movement of cartons and pallets is constant, and accurate counting is crucial. Traditionally, this involves manual tallying, which is slow and error prone. Smart vision systems automate this fully. Smart vision systems automate this fully. Camera placed at docking bays or conveyors count incoming outgoing cartons, detect pallet positions, record SKU volumes, and validate loading patterns. What even more valuable is the integration with ERP or WMS system. This means real-time stock updates, automated GRN generation, reduced pilferage, better capacity planning. So business using this approach have seen improved inventory accuracy and reduced manpower requirement. Now, third is our transport, in which traffic and smart city analytics comes. So cities are using AI vision to manage urban traffic more efficiently. Vision systems identify vehicle types, detect violations such as wrong lane driving, triple riding, signal jumps, and monitor congestion patterns in real time. And the fourth part comes as retail analytics and in-store intelligence. Also, retailers are using object detection to understand how customers interact with products. Vision AI can track self stock levels, product placement effectiveness, customer movement paths, and engagement hotspot. So this helps store ensure on shelf availability, optimize store layout, reduce stock outs, and even improve marketing strategy. It brings the kind of analytic visibility that e-commerce platforms have, but in offline retail. And the last is safety and compliance monitoring. A major challenge in industrial sites is ensuring worker safety, especially in high-risk zones. Vision AI monitors helmet and PPE uses, restricted area intrusions, fire or smoke events, and unsafe behavior patterns. These systems can send instant alert to supervisors, preventing accidents before they escalate. Some factories have reduced compliance violations by more than 60% after deploying vision-based safety monitoring.
Awesome. Thank you for that explanation. And I think definitely vision system is something can be adopted in a lot of use cases and a lot of industries. As well, you mentioned, right? Manufacturing and staffing, and even in traffic. Like I think this is already being taken place, right? I'm sure one of our viewers might have already received some challans or traffic tickets for speeding.
Yes, yes.
I myself have got one. So yeah, definitely. Vision systems
Yeah,
are here. They are
if you are living in a city, then definitely.
right, right. Cool. Let's move on to the next question, Deep, right? If a company wants to build a vision system solution, what is the architecture and tech stack behind it?
Great question, Jibin. When a company decides to build a smart vision system, there's a lot happening behind the scene. It's not just about running an AI model, it's about creating a complete, reliable, scalable ecosystem that can handle real world conditions, messy data, and enterprise level performances. Let me break down the architecture and tech step by step. Now, first is edge devices or cameras. It all start with the hardware. Business usually deploy IP cameras, thermal cameras, industrial cameras, or edge devices like NVIDIA Jetson, Intel NUC, Google Coral, or even mobile devices. So we are going to have a demo with a mobile device today. Okay, so these devices are responsible for capturing high quality video streams, running light inference model on device, and operating in tough environment, dust, heat, vibrations, low light. Now, modern edge cameras also support on-device AI inference, which reduces latency, bandwidth usage. This is extremely useful in manufacturing floors, toll plazas, whereas warehouses, and remote sites. Second part is our AI model, which is the brain of the system. The core intelligence lies in deep learning models trained for specific business scenarios. Depending on the requirement, speed, accuracy, or hardware limitation, we use models like YOLO V8, YOLO NAS for real-time detection, faster RCNN, RetinaNet for high precision tasks, TensorFlow Lite or ONX models for edge deployment, PyTorch models for research-oriented or domain-specific tasks. So we don't just deploy models as is. They go through data collection, annotation, transfer learning, optimization, hardware specific fine tuning. Now, next part is our processing layer, which is edge gateways or cloud servers. Once the camera capture data and model begins inference, we need a strong processing backbone. This layer could be edge gateways placed within the factory or warehouse, cloud servers running scalable inference pipeline, hybrid architecture depending on connectivity and latency requirement. The processing layer handles frame batching, inference orchestration, storing snapshot or metadata, running business rules, streaming results to dashboard. So in high-speed environment like traffic monitoring or conveyor belts, this layer ensures real-time performance. Now, finally is our analytics and dashboard, which turns data into decisions. This is where business users interact with the system. So we build web dashboards that shows KPI like throughput, occupancy, defect rates, productivity trends, violation logs, heat maps, and zone analytics. Tech stacks commonly the tech stacks which we use for this commonly include React, Next.js for frontend, Firebase, Supabase, MongoDB, PostgreSQL for storage. Now we use WebSocket MQTT for real-time updates. This gives managers real-time visibility and help them take action instantly. So at Logic, we combine all these layers, AI models, edge devices, custom mobile apps, dashboards, and enterprise integrations to build complete end-to-end visibility systems. Whether it's counting, inspection, safety, or predictive analytics, the goal is same: real-time intelligence that drive better decisions and operation excellence.
Great. Thanks a lot, Deep. Deep, I think you have nailed down the architecture and the whole, connecting the dots of how vision system works, right? So now I think we are at a stage where we can show our users how it works, right? Let's move on to the demo session where you can, show us actual some demonstration of vision systems.
Yes, Jimmy, we'll do it for sure. But let me walk you through a real project we built recently, something that started as a small experiment and quickly turned into a powerful smart vision use case. So, what was our problem statement? Was my our problem statement was, can a normal mobile phone become an intelligent real-time vision device? Streaming live video to an AI server that detects and counts objects instantly. So for this, we have used mobile for streaming uh, camera feed, and we will divide the whole story in four parts, like mobile story, in which a phone that streams like a smart camera. So
Mhm.
imagine a warehouse supervisor holding a phone. He opens our Flutter app and taps start stream. From that moment, the phone behaves like a dedicated AI camera. So the app captures frames directly from the device camera, converts each frame into raw bytes, streams those bytes continuously over a WebSocket connection, and maintains smooth low latency video even on average networks. The next part is our transport story, which for which we have used WebSockets to transfer bytes from mobile to a Python server. Now, next is our Python server, which is our backend. We built a Python WebSocket server using async IO, WebSockets, OpenCV, YOLO-based models, and tracking algorithms like DeepShot or ByteTrack. So I think last is our business story. Now imagine the supervisor pointing his phone at a conveyor belt, pallet stack, a loading dock, a soft floor safety zone. The app displays counts, tracking safety alerts, and parcel movement and occupancy in a real time. So let me show you the demo.
Yeah, yeah, sure.
So I'm sharing my screen. Give me a few moments. Uh, okay. So, is my screen visible to you?
Yeah, yeah, I can see your desktop.
Okay. Now, so enough about talking. Now, let me just show you the code. So, this is our mobile part. We
Hmm.
have taken a camera stream page. We have built a camera stream page. I can show you this in the. This is our flow diagram. Flutter
Hmm.
mobile app, which will send data through WebSocket stream to a Python server. So it will detect what is in the image frames.
Okay,
Okay. Now, what we are using camera controller to pass the camera data and WebSocket to channel that. Uh, Here we are setting the server URL
hmm,
to pass the data over a WebSocket channel. Okay.
got it.
Now
Yeah.
this is converting the images to bytes, and channel is syncing that. Now let's come to let me run it. Let's come to Python code.
Hmm.
Okay, let me first run it so it will be ready to receive the frames. Now we are using YOLO as a brain. So think it like a child which doesn't know anything. So this is the memory of the brain, right? We will
Got it.
put this memory in the brain. You can say that YOLO v3.txt. This files has the memory of object it can detect. Like this is the list of object it can detect. Okay,
Right.
and this CFG file tells how to do that, and weights file have that complete data to think. Okay. Now we will load these files in OpenCV, cv2.dnn, deep neural network
Hmm.
library, and this will process each and every layer from here, like handle WS. This is handling WebSocket, and this is having the JPEG bytes, and now the processing is taking place. Okay.
Got it. Yeah.
So here we have started our server, which is accepting bytes data on this channel. So now
Got it.
we can start our demo
Mhm.
finally.
Yeah, yeah. Let's show the users.
Okay, okay. Let me just start it again. Okay, here it is running. Now
Mhm.
I'm starting streaming. So here you can see that there is one bottle right now.
Right.
Now I will add some more bottles
Mhm.
in the frame. Now you can see that the bottles are two.
Right.
Now I will add one more bottle. So you can see that the bottles are three.
Right. Right. And this is all real time, right? We are not doing
Yes, yes.
anything else. We are not
No, no,
manipulating
no.
the other screen. This is all real time.
This is all real time data.
Got it. Got it.
So this is just an example of use case that we can
Hmm.
do with computer vision. Okay.
Right. And for this, we have just used our mobile phone, and this kind of system can be developed at any available unit, and we can use any camera stream, right? So in this case, we used a mobile phone. It can be used for any other camera stream that we discussed, right? Like we have a warehouse, and we have some CCTV monitoring cameras, or any other camera that is able to give us good video recording. We can use that, give it to the server, and then the server will give us the data that can be visualized in the dashboard, and details can be shown in the real time, right?
Yes, yes. This demo will turn a mobile device into an AI vision device. Like CCTV cameras are placed on a fixed place, but mobile
Right.
device can be portable. So it can be placed anywhere in your warehouse or your retail shop to detect the anomalies, or you can detect also the soap lifting with the cameras.
Definitely, definitely. Thanks a lot for that demonstration. I think it was really great. Now let's move on to the last question of our today's session, right? With the AI systems and vision systems, developing and going forward, where do you see this technology is heading in the next few years?
Okay, Jibin, we are already seeing exciting trends shaping the next generation of smart vision, like edge AI acceleration, like AI which runs on your mobile locally without calling any API. So, edge AI acceleration, like models running directly on edge devices, removing cloud dependency. Next is multi-modal fusion, combining video, thermal, and sensor data for richer analytics. And then comes 3D vision and depth analytics using LiDAR and stereo cameras for precision tracking. And the final, I think, generative AI for vision, which synthetic data generation for training models faster. So predictive vision systems also are there, in which system that doesn't just see but forecast issues like production bottlenecks or safety risks. So the future is where the vision meets intelligence, enabling environment that are self-aware and adaptive.
Awesome. Thanks a lot, Deep, for walking us through such an insightful and practical exploration of smart vision systems. To everyone who's joined us today, here's the key takeaway for all of you. AI vision is not just about identifying what's in a frame, it's about transforming operations through visibility, accuracy, and automation. At Teologic, we have helped a lot of industries deploy AI-powered vision systems that count, classify, and act in real time, driving measurable efficiency across logistics, manufacturing, and infrastructure. And we are here just getting started. In our next sessions, we'll continue to explore how AI from perception to decision making is turning intelligence into real world impact. Make sure you follow AI Logic Technologies on LinkedIn, YouTube To stay updated on our upcoming webinars and demos, I'm Jumain, signing off. Thank you for joining us today. You have a great weekend.
Yeah, thank you everyone for joining today's session. It was truly a pleasure sharing my experience and walking you through how smart vision systems are transforming industries. I hope the insights we discussed gave you a clearer understanding of where AI vision is heading and how it can create real value in practical scenarios. A big thanks to Alogic Technologies for hosting this platform and to Jubin for steering the conversation so smoothly. I'm excited about the innovations ahead, and I look forward to connecting with you again in future sessions. Have a great day and stay inspired.
All right. Thank you, everyone. Signing off. Bye.
Thank you.